Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Elasticity is one of the defining promises of cloud computing, and AWS Auto-Scaling Groups, or ASGs, make that promise practical. Instead of provisioning servers manually or guessing at future demand, ASGs allow capacity to expand and contract automatically based on real usage. This means applications stay responsive when traffic surges, yet costs are controlled when demand subsides. Beginners should imagine a store that can add new checkout lanes instantly when crowds gather and close them just as quickly when the rush ends. Auto-scaling ensures compute supply flexes with business demand, delivering resilience, efficiency, and predictability. Every auto-scaling group operates within boundaries defined by minimum, desired, and maximum capacity. The minimum ensures at least a baseline number of instances always run. The desired defines the current target capacity, and the maximum prevents scaling beyond budget or architectural limits. These values shape the elasticity envelope of an application. For learners, it helps to picture a thermostat. You set a minimum to keep the room warm enough, a maximum to avoid waste, and a current desired temperature. Auto-scaling uses these thresholds to balance availability with efficiency. Launch templates provide the blueprint for creating instances within an ASG. They specify details like AMIs, instance types, key pairs, and networking settings, and they support versioning for safer updates. Templates also enforce security best practices like IMDSV2, the Instance Metadata Service version that protects against credential theft. Beginners should see launch templates as recipe cards. They don't cook the meal, but they ensure every dish follows the same instructions. By versioning templates, you can roll out updates carefully, reducing risk while maintaining consistency across fleets. Health checks are another cornerstone of autoscaling. EC2 health checks monitor instance-level metrics, while load balancer health checks evaluate whether instances actually serve traffic correctly. By combining both, ASGs avoid the trap of keeping technically alive but unresponsive servers in rotation. Beginners should picture this as not only checking if a cashier is standing at the register, but also verifying whether they are actually processing customers efficiently. Auto-scaling automatically replaces impaired instances, restoring health without human intervention. Scaling policies define how ASGs respond to demand. Target tracking adjusts capacity to maintain a metric like CPU utilization or requests per target. Step scaling adds or removes instances in defined increments when thresholds are crossed. Scheduled scaling pre-provisions capacity based on known patterns, such as business hours. Beginners should imagine traffic lights. Target tracking works like adaptive signals adjusting in real time. Step scaling is like adding lanes when congestion spikes. And scheduled scaling is like planning rush hour staff shifts. Each policy type aligns to different workload behaviors. Cooldowns and stabilization windows prevent overreaction to temporary spikes. When an ASG adds or removes instances, it pauses further actions until the system stabilizes, avoiding oscillations. Beginners should think of this as pacing during exercise. Sprinting too often without rest leads to burnout. Cooldowns give the system breathing room, ensuring scaling decisions reflect sustained demand, not momentary blips. Misconfigured cooldowns are a common pitfall, leading to thrashing and unnecessary costs. Lifecycle hooks extend control by pausing instances at critical moments, such as when they are pending launch or terminating. This allows administrators to run configuration scripts, attach monitoring agents, or gracefully drain connections before removal. For learners, lifecycle hooks are like onboarding and offboarding checklists for employees. New hires complete paperwork before starting work, and departures ensure duties are handed over. These hooks give teams the chance to integrate automation smoothly into scaling events. Instance refresh is a modern feature that allows rolling updates within an ASG. Instead of replacing all instances at once, it gradually replaces them with instances launched from an updated template. Health checks ensure only healthy replacements continue the process. Beginners should think of this as renovating a hotel room by room while the rest of the building remains open. Instance refresh makes updates safer and keeps services online even during major infrastructure changes. Warm pools speed up scaling by keeping pre-initialized instances ready for quick activation. Without them, scaling out involves launching brand new instances, which can take time as AMIs load and applications initialize. Warm pools reduce that lag by staging instances ahead of time. Beginners should imagine preheating ovens before dinner service. When orders come in, meals are ready faster. This feature is particularly valuable for unpredictable surges where seconds matter for responsiveness. Mixed instances and allocation strategies enable ASGs to balance cost and resilience. By blending on-demand, spot, and different instance families or sizes, ASGs diversify capacity sources. Allocation strategies like capacity optimized choose spot pools with the best availability, reducing interruptions. For learners, this is like stocking a store with goods from multiple suppliers. If one runs out, others can fill the shelves. Diversity ensures both cost savings and stability, especially under fluctuating demand. Capacity rebalancing further improves spot resilience. When AWS detects reduced availability in a spot pool, autoscaling proactively launches new spot instances in healthier pools before terminating the old ones. Beginners should think of this as shifting guests from a crowded restaurant to one with empty tables before they even notice discomfort. Capacity rebalancing smooths transitions and avoids abrupt interruptions, making spot a more reliable part of autoscaling strategies. Multi-ES distribution is a built-in best practice with ASGs. By spreading instances across multiple availability zones, applications achieve resilience against zone-level outages. Beginners should imagine storing valuables in multiple safes across town, rather than relying on one building. If one safe is compromised, others remain intact. Autoscaling automatically balances placement, ensuring redundancy is not an afterthought, but a core design principle. Termination policies decide which instances are removed when scaling in. Options include terminating the oldest instances, newest ones, or balancing across availability zones. Each has implications for cost, compliance, or resilience. For learners, think of this as deciding who leaves first when a bus is overbooked. Long-time passengers, recent arrivals, or evenly across rows. The right policy ensures efficiency and fairness in scaling decisions. Metrics drive everything in autoscaling. Common signals include CPU utilization, request counts per target, and queue depth for worker processes. These metrics reveal whether the system is stressed by computation, traffic volume, or backlog. Beginners should think of them as medical vital signs: heart rate, blood pressure, and oxygen levels. Each points to different health issues, and monitoring them all ensures accurate diagnosis. Autoscaling reacts intelligently when metrics are chosen carefully and aligned with business goals. Predictive scaling extends this intelligence by forecasting demand with machine learning. By analyzing historical patterns, AWS can anticipate traffic surges and scale proactively, rather than waiting for alarms to trigger. Beginners should imagine a cafe that hires extra staff before the morning rush, because it knows patterns from past weeks. Predictive scaling combines historical analysis with proactive capacity, reducing latency and smoothing user experience. On the exam, predictive scaling signals AWS's ability to go beyond reactive elasticity. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Selecting the right policy type begins with mapping metrics to business goals. If your goal is to keep CPU utilization around a comfortable range, target tracking policies are ideal. If the business requirement is to handle abrupt traffic surges, step scaling policies make more sense, as they allow aggressive adjustments in response to thresholds. Scheduled scaling fits when patterns are well known, such as day-night or weekday-weekend cycles. Beginners should imagine managing a team. Sometimes you adjust staffing in real time. Sometimes you hire extra people for big events, and other times you simply plan shifts around the calendar. Each scaling policy aligns to a different rhythm of demand. Target tracking deserves special attention. Instead of watching raw CPU, many organizations choose request count per target, which aligns scaling with actual user load rather than internal performance. For example, maintaining 100 requests per target ensures consistent user experience regardless of back-end efficiency. Beginners should see this as running a restaurant. Rather than hiring staff based on how tired the chefs feel, you scale based on the number of customers waiting. By connecting policies directly to service demand, target tracking aligns infrastructure with business outcomes more effectively. Step scaling excels when workloads face abrupt changes, such as marketing launches or flash sales. By defining multiple thresholds, ASGs can add a few instances for moderate increases and many for sharp surges. Beginners should picture this as a dam releasing more gates as water rises. Gentle flows require small adjustments, while floods demand drastic action. Step scaling ensures responses are proportional, protecting availability without overcommitting resources during minor fluctuations. It's a practical model for spiky, unpredictable workloads. Scheduled scaling works best for diurnal or calendar-driven workloads. A news website may experience predictable peaks every morning and evening, or a financial application might spike during market hours. Scheduled scaling allows you to add capacity before the surge and reduce it after demand subsides. Beginners should imagine an amusement park hiring seasonal staff before summer begins. By aligning scaling with time-based knowledge, organizations avoid the lag of reactive policies and reduce costs by scaling down outside of peak windows. Health remediation is a natural benefit of auto-scaling. When an instance becomes impaired, whether through hardware failure or software crash, the ASG terminates it and launches a replacement. This makes recovery automatic and continuous. Beginners should think of it as a factory where broken machines are swapped immediately with working ones, without halting production. Health remediation reduces operational burden and guarantees that the system heals itself, one of the hallmarks of cloud-native resilience. Blue/green deployments can also be orchestrated with autoscaling. By creating a new launch template and refreshing the ASG, you can gradually replace all instances with updated configurations or software versions. This minimizes downtime and risk. Beginners should compare this to renovating a hotel. New rooms are opened one floor at a time while old ones are phased out. Guests never lose service, and the building is upgraded steadily. ASG refreshes make this possible with automation and health checks ensuring safety. Integration is one of autoscaling's strengths. ALBs and NLBs automatically register new instances as targets. SQSQs can signal scaling events for worker fleets, and Lambda can be used to trigger or customize scaling behavior. Beginners should see this as a concert where different performers, servers, load balancers, queues, all play in harmony under a single conductor. The ability to tie autoscaling into the wider AWS ecosystem ensures that elasticity is not just about EC2, but about the entire application stack responding cohesively. Cost posture improves dramatically with autoscaling. Instead of provisioning for peak load, you right-size baseline capacity and let the group scale with demand. This avoids the waste of oversized servers running idle most of the time. Beginners should picture heating a house. Rather than blasting the furnace all day, you maintain a comfortable baseline and turn up the heat only when the temperature drops. Auto-scaling enforces financial discipline, ensuring you pay for what you use while still meeting user expectations. Testing scale is an often overlooked practice. Organizations must simulate load with stress tests or game days to verify that policies work as intended. Without testing, scaling failures may surface during real incidents, when the stakes are highest. Beginners should think of this as fire drills. You don't wait for a real emergency to discover whether exits are usable. Practicing scale events validates thresholds, cooldowns, and integration, giving confidence that the system behaves correctly under stress. Observability is critical to successful scaling. Dashboards display key metrics, alarms trigger responses, and runbooks provide step-by-step instructions for handling anomalies. Beginners should imagine an air traffic control tower. Without screens, alerts, and procedures, chaos would ensue. Auto-scaling depends on observability not only to act, but to explain why it acted. Clear visibility allows teams to adjust and refine strategies, making elasticity smarter over time. Guardrails prevent scaling policies from overreaching. Service control policies can limit what auto-scaling does across accounts. Quotas set ceilings for resources, and AWS limits protect the platform itself. Beginners should see this as installing governors on engines. They ensure cars don't exceed safe speeds, even if drivers push too hard. Guardrails create confidence that automation won't spiral out of control, protecting both costs and architecture stability. Failure drills prepare teams for insufficient capacity responses. Occasionally, scaling events may fail because AWS regions lack available capacity. While rare, these scenarios require fallback plans, such as spreading load across regions or shifting work to alternate compute types. Beginners should imagine a concert venue overbooked. Some guests must be redirected to a different hall. Practicing these drills ensures the system remains resilient, even in constrained conditions, reinforcing a culture of readiness. Documentation ties scaling into governance. Recording scaling policies, service-level objectives, and approval flows ensures the organization understands how and why automation behaves as it does. Beginners should think of this as publishing rules in an employee handbook. Without documentation, scaling decisions can appear random or unaccountable. With it, elasticity becomes structured, auditable, and trusted. Common pitfalls with auto-scaling include misconfigured cooldowns that cause thrashing, using the wrong metrics that don't reflect true demand, or failing to distribute across availability zones. These mistakes undermine elasticity, causing unnecessary costs or outages. Beginners should picture a thermostat placed next to a drafty window. It reacts constantly, but inaccurately, failing to regulate the house. The exam frequently tests recognition of these pitfalls, rewarding answers that emphasize alignment between metrics and real workload behavior. On the exam, auto-scaling is often the correct answer whenever elasticity, fault tolerance, or cost efficiency are mentioned. If the question involves replacing failed instances automatically, handling diurnal traffic patterns, or scaling workers with queue depth, auto-scaling is implied. Beginners should train to recognize these cues quickly, mapping workload requirements to ASG capabilities. The exam does not require building configurations, but it does require identifying when auto-scaling provides a solution. In conclusion, auto-scaling is the heartbeat of elasticity in AWS. By defining clear policies, testing scale events, and monitoring continuously, organizations keep applications responsive and cost-efficient. For learners, the lesson is to see auto-scaling not as a bolt-on tool, but as the natural operating mode of cloud workloads. Elasticity is the difference between static servers and dynamic systems that adapt in real time. By mastering ASG concepts, you align infrastructure with both technical performance and business value, ensuring systems are resilient, efficient, and ready for change. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.